Mr. Vivek Sarwate, Country Business Unit Head, Distribution Systems and Future Grid at Siemens. He is a BE graduate in electrical engineering and an alumni of Arizona State University. Mr. Sarwate has ample experience in the power industry, associating with leading companies like Alstom T&D and Schneider Electric. He is an entrepreneurial leader with global exposure. Today, Mr. Vivek will be talking about making electricity smarter to create environments that care. So let's welcome Mr. Vivek.
The topic today I'm taking is making electricity smarter. And why do we want to make electricity smarter is very important because it is important to create an environment that cares, not only for us, this present generation, but also for generations that are going to come behind us. We need to give them safe environments and smart environments. Diving directly into the topic, all of us know that India is going through the largest urban transformation of the 21st century, maybe something what China went through a few years back. With 1.33 billion of population, which maybe in the next 3 to 4 years will become the largest population in the world, even surpassing China. 25%, 50% of India today is below 25 years of age, and nearly 65% below 35 years of age. So this presents India with a large opportunity. We know that all the new employment which is happening, nearly 70% of that is happening in cities, with more manufacturing happening, with service sectors coming to the cities. Urbanization is happening very, very fast. And today, approximately 70% of India lives in villages. That number will come down to 50% by 2030 or 2040, depending on how fast urbanization happens. So India is changing at a very fast pace. And along with that, digitalization is happening very fast. All of you know, in last 5 years, we have multiplied the number of mobile phones in India by 50. This is a rapid revolution which is happening. India is digitizing very fast. And this is also leading to climate change. 40% of energy that we are using today is happening in the buildings. And 25% of carbon dioxide emissions, which is happening in India, is coming from these buildings. So if connect all of these dots, it means that we need to manage our electricity very, very well. And I also say that, out of different form of energies that we use, whether it is coal, oil and gas, and electricity, out of different form of these energies, electricity is the cleanest form of energy. And therefore, more and more electric we become, the faster we can make our environment more and more sustainable. So I think that is something that we should always keep in mind. Now, with this growing energy requirements of India, when by 2030 will be not only the most populous country in the world, will also be third biggest energy consumer in the world. And with global warming happening, it is leading to a very great emphasis on optimizing and conserving energy depending on how we are using it. So there are three trends that we are seeing across. The first is decarbonization, second is decentralization, and third is digitalization. Now, what does this mean? 3 Ds. The first is decarbonization. You know that with focus on global warming, everyone wants to reduce the use of energy, and which means that either we convert energy producing variety from, let's say, coal into renewables, and at the same time, a watt which is not used is the best form of energy conservation. So energy efficiency becomes more and more important. How can we reduce from using 100 watts today to, let's say, 50 watts tomorrow? That becomes very, very important. Second is decentralization, and I think India is going through this revolution right now, but we are only at the tip of the iceberg. We see more and more renewables coming in. In India, this transformation has been really rapid, and this is going to continue. We see in the next 4 to 5 years, big ambitions are there. So with growing share of renewable energy, decentralization of energy also happens. A lot of you will also have a solar on your rooftops, on the top of your factories, on the top of your offices, in your happening fast. And is digitization or digitalization, whichever way you want to look at it. A lot of data is getting generated because we are connecting systems together. Without connecting, you cannot make a decision. Unless you collect data, you connect the data together. Only then intelligence can be built into it, which becomes very, very key for decision making. So digitalization is a third key trend which is happening globally. So with these key trends, as a manufacturer, of smart products and smart services support in making electricity smarter. So what can we do is the question. Now, if you see, if you divide the complete energy equation, you can typically see this into two parts. The first part is on the demand side. Demand side means all the users of energy, whether it is industry or buildings, consumers at home. And with urbanization happening a lot more, we saw earlier that buildings have become more and more important. So typically we have to energy demand side, where we work with all of these consumers of power, and especially large consumers of power, to make it more efficient. So we provide technologies for building automation, for fire safety, security. We provide products and solutions and those services to industries, basically to make it more and more smart, so that they are able to optimize their systems. On the other side is the energy supply side, something like a Tata Power, where we again support them by supplying smart equipments like low and medium voltage switchgears. We support them with automation of grid. And these has been, I would say, these two sides are more historical in the way they were working. And the flow of power always used to be from the energy supply side to the energy demand side. Now, this is changing very fast. And you know that even on the demand side, people are starting to produce. So you see buildings putting up the solar power plant, or industries putting up solar on their rooftops. And what this is doing is this is converting the typical energy equation, which was unidirectional earlier, into bidirectional flow, which means users are no more only consumers, but they are prosumers, which is a combination of producers and consumers. So this is making the complete equation more and more complex. So what we talk about today is a lot of the new transformation which will happen on the edge of these two fields, which is on the energy side. The edge of that is what we call as grid edge. And on the grid edge is where I feel a lot of transformation will happen in coming years. And what will support it is the digitalization. Because a lot of data will be connected in these spaces, a lot of new services will come in, and a lot of new business models will come in. So if we focus on this equation here, which is the grid edge plus digitalization, you will see multiple things will happen. The first is, as you see more and more consumers becoming producers, a lot of energy will become decentralized, and you will need systems to support this decentralized energy in the networks. You also know that renewables are not on all the time, which means that you will need systems to understand when renewable can supply and when it cannot supply, so that you can manage your system better. This complication is not easy because grids need to be stable. It is very important. Power quality has to be of good quality all the time. That will be needed by the customers. So it will be a complex equation, and therefore you will need sophisticated systems to manage this. The key here would be that more and more sensors that we can put inside the devices will be very, very important. You will see communication systems, as Mr. Kane was saying earlier. The communication and it remains a challenge. How can we do it for at a reliability that we need? That will become more and more important. A lot of data will be generated, which means that we're adding computers into the whole thing. A lot of automation will happen here. So this whole field is going to go through a revolution. Along with that, you also know that when they're producing power, the power which is produced during the peak times is the most expensive power. And during the valleys, when the power demand is less, that time the power production rate is the cheapest. So which means that there is a need for a sustainability drive to happen. There is a need to shave off the peaks and fill the valleys, which means that we should have a more stable energy demand throughout the day. And again, that will happen a lot with collection of data, with artificial intelligence, with even the customers becoming more and more knowledgeable about how they are using power and supporting in this initiative. And all of this smartness will drive sustainability. What will also happen is you will see that energy storage devices will come in. And I think Tata Power is again one of the pioneers in that field, where we had worked, Fluence, which is a Siemens company, they had worked with Tata Power to put up, I think, a 10 megawatt energy storage in Delhi, which is, I think, first in India and amongst the largest in Southeast Asia. So energy storage, battery energy storage will pick up in coming years. That will be very important to shave off peaks. E-charging will happen more and more. As I said earlier, the cleanest form of energy is electricity, not oil and gas. Burning diesel will be a crime. Burning petrol will be a crime in future. So e-charging vehicles will happen more and more. A lot of regulation is also happening in that direction with government pushing the FAME scheme. And I think by 2030, India is one of the countries where the electric charging facilities would be there. So these are the trends which we see, which are going to happen in coming days, months, and years, and they are going to really drive how we make our electricity smarter. Now, just for that, I wanted to take you through one case study, because the future is already here. This case study is coming in from Carlsberg. So Carlsberg is one of the largest manufacturer of beverages in the world, and in one of the years they took an ambition that they really wanted to reduce the carbon dioxide emission on the power that they were using inside their facilities. Now that was the ambition with which they started talking to us, and we collaborated with them to create end-to-end solution. And this is where the technologies I'm talking about, grid edge, most of those technologies came at one place. So we started with looking at their buildings. We had a design OCC which really helped them to optimize their buildings, when to use power, how to shave out the peaks, how they were using power inside their buildings. So that was really important. Then we worked on DEOP, which is distributed energy operating practices, and we basically provided a microgrid solution to them here, through which they could make the best use of options available to them, which was using renewable power, using power coming from the grid, many times from thermal sources, which is not the best form from a sustainability point of view. And they also implemented the battery storage. And just to give you an idea of how big this was, it was 20 megawatt battery storage solution that they put, and the size, the physical size of the area was nearly half the size of the football field. That was the amount of space which was required to put up this 20 megawatt solution. But we supported them was, we started with consulting as to what is the best way for them to reduce their carbon dioxide footprint. We supported them with grid simulation, because it is very important to keep the grid stable when you're putting all of these solutions. Efficiency was the most important part, because unless you become efficient, you cannot cut your carbon dioxide emissions. We worked with microgrids and distributed energy optimization, both together, because with that, not only were they able to optimally use their battery storage that they had put, but they were even able to power back on it, which means that they were able to monetize the investment that they did on the battery storage. So this was very important for them to bring down their return on investment. And last but not the least, they also made their complete facility EV charging capable, and they put up a lot of EV charging places and basically incentivize their employees to move towards electric vehicles. So this is one case study where we feel that the grids are going to become smarter in coming days. I think we are in a very early stage of seeing how this can work out, but the road ahead is I would say very, very optimistic and very exciting.